What we're going to be doing is looking at dividing rationals again. These ones are not factored for us. So if we're looking at the first one, remember whenever we're dividing, we keep the first fraction, we change the division to multiplication, and we flip the second fraction. So keep, change, flip. So we have 8x to the fourth, y to the fifth, x to the third, y. We change it to multiplication. 2x to the negative 3, y to the seventh, 4x squared, y to the third. Next thing that we're going to do is we're going to multiply across. 8 times 2 gives us 16. Then we have x to the 1, and then y to the 12th. For the denominator, 4 times 1 is 4, x to the fifth, y to the fourth. 16 divided by 4 gives us 4. We subtract the exponents. Since there's more x's in the denominator, we put the x in the denominator. Since there's more y's in the numerator, we put the y in the numerator. 12 minus 4 gives us 8. Now, stating the excluded values. With the excluded values, it's what gives us 0 in the denominator. So x cannot equal 0 and y cannot equal 0. Remember, whenever it's a monomial, it's always going to be 0. For the next one, what I'm going to do is I'm going to flip and factor at the same time. So I see a x in common, and that gives me an x plus 2. Then we have a 2x to the fifth. I change it to multiplication, 5x squared over, and then x squared minus 4 is a special factoring pattern. We could take the square root of both of them, x minus 2, x plus 2. Now what we're going to do is we're going to cancel. And we see that the x plus 2's cancel. We see that the x squared and x to the fifth, they cancel. And then we could cancel the x again. And that would be 2. So that would give us 5 over 2x squared and then x minus 2. Next thing is the excluded values. So when we're stating our excluded values, we're looking for what gives us 0 in the denominator. A monomial would be 0. The opposite of negative 2 is 2. The opposite of 2 is negative 2. And remember, this was once in the denominator, and that is also 0. But since we already have a 0 here, we're not going to add it again. For letter C, we see that they have a 2 in common, and that would be an x squared minus 25. And that factors as x minus 5 and x plus 5. For the second one, we see they have a 2 in common, and that gives us an x squared plus 5x plus 4. And that factors as two numbers that multiply together give us 4, add up to 5, which would be 4 and 1. So we have the 2 on the outside. And then we have x plus 4 and x plus 1. I'm going to factor and flip the problems at the same time. So my denominator is now my numerator. Two numbers that multiply together give me 20, add up to 9 would be 4 and 5. So x plus 4 and x plus 5. Then our numerator is going to become our denominator. So two numbers that multiply together give you 25, add up to 10 would be 5 and 5. So that would be x plus 5 and x plus 5. What we're going to do next is we're going to cancel. We see that the x plus 5s, the x plus 5s again, the x plus 4s, and the 2s. So our answer is x minus 5 and x plus 1. Now, excluded values. What gives us 0 in the denominator? For the first one, opposite of 4 is negative 4. Opposite of 1 is negative 1. Opposite of 5 is negative 5. We already did the 5. Remember, these were once in the denominator. Now they're in the numerator. So looking at that, that would be -4, which we already have, and -5, which we already have. So these are our excluded values. Pause the video, try those next 3 on your own and see how you do. Okay, looking at letter D. Once again, what we're going to do is we're going to multiply by the reciprocal. So we have 4x to the 5th y, x squared y squared, times 3x to the 4th y to the -1. 8x to the -2 y to the 6th. We're going to multiply across. 4 times 3 gives us 12. X to the 9th. This is a 1. 1 plus -1 is 0, which anything to the 0 is 1. 8 times 1 is 8. X squared, x to the -2. That gives us 0. X to the 0, of course, is 1 also. 2 plus 6 gives us 8. Now, 12/8 reduces to 3/2. And that would be x to the 9th and y to the 8th. Now, excluded values, remember monomials are always 0. So x cannot equal 0 and y cannot equal 0. Okay, for our next one, once again, I'm going to factor and flip it at the same time. So I factor out a 2x, and that gives me an x minus 4. I change the division to multiplication. This is a special factoring pattern, so that would be x minus 4 and x plus 4. I have a monomial, so I'm just going to keep it in the denominator. And what I'm going to do next is cancel. So I see the x minus 4's canceled. I see that, let's see, the 7 cancels with the 14. X squared and x to the 5th cancel. And so 1 times x plus 4 is just the x plus 4. 2 times 2 gives me a 4. X times x cubed is x to the 4th. For the excluded values, it's what gives us 0 in the denominator. So x cannot equal 0 for the first one, 4 for the second one, 0. But remember, these were in the denominator. So we also have to check those. That would be a positive 4. That would be a negative 4. Okay, last one. Looking at this, we're going to factor and flip at the same time. I see that they have a 3 in common, and that gives me a 2x minus 3. They have a 3x in common, and that gives me an x plus 1. I'm going to change it to multiplication. I'm going to put the denominator in the numerator. So 2 numbers that multiply together give me 2. Add up to 3 would be 2 and 1. So x plus 2, x plus 1. And then for the last one, I'm going to multiply the 4 and the 9, and that gives me 36. Adds up to -12, which would be -6 and -6. Because the leading coefficient is 4, I divide each by 4. Now, notice that 6/4 can be reduced. It can be reduced to -3/2. So that means that when we bring the bottom to the top, 2x minus 3 and 2x minus 3. I'm going to look to see what I could cancel. The 2x minus 3's, the x plus 1's, and the 3's. So I have x plus 2, and I have an x and a 2x minus 3. Now, when I'm looking at the excluded values, what gives us 0 in the denominator? And once again, the reason that we find the excluded values is because we can't divide by 0. So these are the values of x that we can't have, otherwise our problem is not valid. Monomial gives us a 0. This is the opposite of 1 is -1. This right here would be 3 over 2, and 3 over 2, and -2. -1, which we already have, so we're not going to put it again.